I just wanted to ask that how we can maintain the particle size consistently batch to batch wise.
It's very important when you start synthesizing it. Keep in mind that your precursor's amount and the molar ratio. These two parameters, if you can play correctly, like for are you a chemist or physicist?
Chemistry.
No, then you would be much better than me. Then catalysts play a very good role. Then what is the ratio of like resorcinol to catalyst? What kind of ratio you are putting in? 500, 1000, 2000. There is Aerogel handbook. You can see from 100 R by C ratio. R by C means resorcinol to catalyst. To 3000 they have gone. Even I have published one paper up to 3000. Everywhere morphology changes. If you are a beginner, try to restrict yourself with R by C only 200 or 5 or whatever the magic number, it works for you. And then you go for this morphological structure. Once it coming, then after 3 or 4 iteration, then only you change that parameters. That can be the best to control this spherical size as well as
just to maintain the concentration and starting with that.
Because I have tell you only one R by C. There is R by W also. Means if you are taking that water, DI, distilled water, then also this resorcinol to DI water, it changes. As a chemist, you would be knowing. If I keep 3 mg milligram catalyst and I start, increasing water, you will say, okay, catalyst is kind of dead weight. What will be the response? But there will be huge response in it. Because that polymerization, that's cross linkage, that totally depends on what kind of precursor, like resorcinol to formaldehyde, resorcinol to water, resorcinol to catalyst. I hope I answered you.
Thank you, sir.
Yeah, please.
Hello sir, nice presentation. So my question is with respect to TM. Like you said that carbon-based materials, if they are amorphous, can we understand whether they are crystalline or amorphous from TM? Like mostly materials like Geo, Argeo show the hexagonal arrangement or pattern, specifically with respect to crystals and rings. So we conclude it as crystalline or polycrystalline. So how to identify amorphous material like polymers or anything?
TM.
Yeah.
Yeah, it's. I think you may not have gone through that. There is a CD pattern.
Yes.
When you take that images, you just put on wherever you are seeing this localized region. Try just to close one aperture and other one. You will see a CD pattern. If there is a a diffuse peak, you will get a clear signature. Okay. Yeah.
Hello sir, I have a question.
Yeah, please.
Lithium batteries are infamous for not working in cold temperatures or hot temperatures. Like energy drain out हो जाता है. So how did you solve that problem?
In animation what I showed. Were you watchful? In animation I showed that they are draining sometimes. They are means I have not shown my results of lithium. Because I worked even at ISRO. I was trained in that lithium battery. But in lithium, whatever the issues are, that temperature which you are mentioning, that people are trying to address. Like LFP battery, you may have heard, Reliance is putting so many monies for it. Like Ola's owner, they face the same issues. So of course there are the real challenges, whatever you are mentioning. So people are doing. I saw that there may be alternate. Why not aluminium, air? Why not sodium? Even sodium ion batteries result I have not shown because in 20 minutes it was not as such criticism. So you have to optimize your material. You have to look like when you said that temperature range. Just try to see the list of the material which has already been taken by the industry, not in literature. I would suggest, although the publishers are there, I won't suggest ki go with blind side. Okay, they have published that will come out. No. Try to see if industry has taken that material and they have approved it at their TRL 7 or 8 level, that will be the best one to modify. From there you start. Okay. Thank you.
Is there any questions from the audience?